Hello, everybody. My name is Austin Carr. Welcome to another episode of the Greenlink podcast. Today, I'm joined here by Mr. Jarron Dundas, our HVAC technician. Jarron, thanks for joining us today.
Absolutely. Thanks for having me.
Yeah, looking forward to chatting and talking shop with you. You actually just got out of a training this week with Mitsubishi.
I did.
Yeah.
It was very informative.
Yeah, that Mitsubishi product and some of the things, the technology that's going on there has been pretty incredible. And a little bit of a learning journey for all of us because it's so new, but a lot of really cool stuff that can happen with that equipment, right?
There is a lot of really cool stuff that you can do. And Mitsubishi is really, they are the leaders right now in mini splits, ducted heat pump systems, just what their systems can do and how they work, and their efficiency is just amazing.
Yeah.
And what they've got coming down the pipeline right now, it's they really are on top of their game. Yeah,
right?
For sure.
I hear there's a couple other manufacturers that are working on kind of getting up to that level, Daikin and some other folks. I don't get too into all the technical and the specs of like who's beating who, but I know that Mitsubishi seems to be the kind of the golden standard in the heat pump world.
They really are. Their inverter-driven compressor system is second to none. They really have the market cornered when it comes to what their system can do and how they want it to function, and just the ability that, at negative 13 degrees, we're still able to maintain 80% of our heating capacity. Nobody in the market right now can do what their equipment can do.
Right. Yeah, that's really cool. So actually, I'd love to just share a little story about that. So this past year, obviously, you were here and we were working the phones together during this event. But in early January, we had a really cold burst here in northern Illinois. We had some negative 10, negative 15 degree weather. And we were calling customers and saying, hey, how are you holding up? How are you doing? And there were some different things that we needed to go adjust some settings and some controls on. But with several of the customers, they were operating off that heat pump and even operating without any auxiliary resistance heat on those systems and maintaining and satisfying the thermostats in the home at that temperature outside of that negative 10. That blew my mind.
It really is amazing what their systems can do. And like you said, right, the majority of our customers were not using their supplemental heat at all.
Yeah.
They were maintaining 70, 71 degrees with just their heat pump, and we're negative 10, negative 13 outside. Figure the wind chill. Yeah. We're down negative 20, negative 25, and those things are still running like a champ and doing what they're supposed to do.
That's crazy, man. So how would you explain to kind of the layman, a homeowner, or somebody that's not in this world, what's kind of the high level basics of what is a heat pump? What does that mean as opposed to a gas furnace?
So a heat pump is basically an air conditioner that has the ability to switch the refrigerant flow, and now we're removing heat from outside in the wintertime and using that to heat the house in the inside.
Transferring that inside.
Yeah.
Yeah. And so you're not using with these systems, I guess if you went with a dual fuel, you would have, gas and a heat pump. But if you're just on a straight heat pump, maybe with electric resistance heat, so fully electrified, like we're doing for some of our customers, you have no gas, and this is just 100% all using electric.
Correct.
Yeah, that's amazing. And so in those situations, and some folks are like, well, what if it gets too cold? That's where you have that electric resistance heat for that supplemental.
Correct.
To give you some additional BTUs if you need them, right?
Correct.
Yeah.
The way that system is designed is primarily the Mitsubishi system. The electric heat is only coming on when our outdoor unit is in defrost mode. So when we get really cold outside, you'll see those coils will start to frost up a little bit outside. Sure. The unit will kick into defrost mode, so we'll thaw out that outdoor unit. But while we're in defrost mode, we still might not have satisfied our call for heat at the thermostat.
Got it.
So our supplemental heat kicks on to assist and help maintain, so we're not just blowing cold air through the house while that system is defrosting. You brought up dual fuel, and there again, Mitsubishi just brought out a new product new this year that is I'm really excited to get out there and put them in. It's called the Mitsubishi IntelliHeat system. Yeah. So we can basically take anybody's existing furnace and turn it into a dual fuel system with a high efficiency heat pump outside, and then we can either set a temperature. So we say at 25 degrees, we don't want to use our heat pump anymore because it might not be as efficient. Mm-hmm. So we can then fire off our gas-fired furnace.
Yep.
It's got a smart technology in there. So say we set for 32 degrees and it notices that we're running way too long. It will automatically switch over, and then it will change the run times on the heat pump, constantly trying to get back to that spot.
Wow.
But it is continually monitoring and switching, and it will tell the system when to come on and when not to come on to make sure that we are getting the most bang for our buck out of what we're doing with the system.
Yeah, so it's really using some kind of algorithm to try to, you can program some stuff, but it's also going to use its brain, software brain, and run some kind of algorithm
Correct.
to transfer back and forth as it sees fit for optimal performance.
Correct.
And so that kind of ties into, when I say algorithm, it starts to make me think about the inverter-driven compressors. Is that the term, right?
That is correct.
What is that? What does that mean? And
So an inverter-driven compressor, so as opposed to a regular compressor that just comes on and comes off, they want their compressor to come on. We're going to ramp up to, say, 125 hertz, and we're going to satisfy that temperature right away, but then we're going to slow that system back down, and then we're just going to constantly be running. So the system is designed to run much longer run times, but that is what they want to do. I mean, just like when you start and stop your car, turn your engine on and off, that's when you're using your most gas, right? When you're starting that engine. So when we're using our most power when we're starting, stopping, not to mention wear and tear of the compressor. So they design their system to kick on, and then we want to maintain.
Yeah.
And it also, the whole thing runs on DC voltage for the most part, as opposed to alternating current or AC voltage. So instead of having the highs and lows of that alternating current, we're basically just maintaining an energy, right? Our electricity is at one constant power level as opposed to jumping all over the place.
Big hits on your starting amps and everything else that goes with that.
Correct.
That makes me think, and I use an analogy a lot, just kind of like you did actually, with the vehicles, right? So city miles is kind of how I relate it to people sometimes, like starting, stopping, accelerating, decelerating, versus your highway miles. You get on, you get those RPMs locked in, and you're just kind of sailing right along. You get those higher miles per gallon. It's better on the vehicle. Even when people are selling a vehicle and say it's higher mileage, you're like, well, these are all highway miles. And it's because it's kind of common knowledge that highway miles are going to be less wear and tear.
Right. Absolutely.
And it's the same thing with these inverter-driven compressors. And I think about it too, and that starts to impact like the sizing. Why would you want that runtime? Think about dehumidification when you're cool in the cooling season and you're banging that thing off and on, and you're satisfying that thermostat too quickly. From what I understand, you're not going to dehumidify the way that you would if you had that nice runtime.
Correct. That is absolutely correct, which is why when we go out and we look at a job, we always do a manual J. We do an assessment of the house. We do an energy audit. We look at things, and we want to make sure that that equipment is sized properly, because if we're too small, obviously it's going to be running all the time, but not for a good reason.
Right.
Because we're not maintaining, or we're never satisfying that thermostat where if the system is sized properly, we'll get that runtime, but we will get that extra dehumidification, as opposed to like if you walk into somebody's house and it's cold, right? Like ice cubes inside, but it's clammy. That's because we're not removing that moisture out of the house. So that unit's coming on, satisfying, and then it just it stops running. Where the system will continue to run, so that we do get that extra dehumidification out of the house. So if you usually keep your house at 72 degrees in the summertime, you might find that that's way too cold with a system like this. You're going to bump it up to 73, 74, maybe even 75.
It's a whole different feel.
Correct, because we're removing that moisture out of the air on top of just satisfying a temperature setting in a thermostat. Yeah,
so it's the whole environmental impact within the home, environment of the home. It's the moisture control, it's the runtime, the temperatures, and so one of the things I think about with this too is, again, giving an analogy about a single stage compressor. It's like a light switch. You're off or you're on.
Correct.
Some people, and you've been in HVAC for decades, you know this better than I do, but people will call and be like, well, I'm not able to hit my set point. I got let's say it's the heating season. I've got my thermostat set at 89 degrees and I'm not hitting my set point there. It doesn't seem to me like it's common knowledge for everybody out there that when your thermostat is calling for heat or calling for cooling, it's just telling the system, hey, turn on and start to do your job, or turn off and you're done doing your job.
Correct.
It's not like I think probably because of automobiles, people have the little heating and cooling and they can select that knob.
Sure.
I think that must be what throw people off on that.
I think you're probably not too far off there. And a lot of times people think, well, it says my thermostat has reached temperature, but it feels cold in my house or whatever. Well, maybe your furnace is slightly oversized, and yes, we're hitting that temperature, but we're not really warming up the house. Yeah. We're just satisfying that thermostat, and then the rest of the house is cold. It also has a lot to do with where is that thermostat located.
That's a good point.
Are we centrally located? Are we sitting right on top of a supply? Am I sitting next to a return duct where I'm pulling cold air back past, or I'm blowing hot air on the thermostat? Am I getting blasted by sunlight throughout the day, and the thermostat thinks that it's the right temperature in the house, but it's not the right temperature in the house? So that has a lot to do with how a system functions properly as well. which is a nice thing with the Mitsubishi system, is that it has a wireless controller. We can put that thing anywhere in the house,
right?
And we can patch over where the old one was and put it in a good location where it's not getting blasted by sunlight. We're not getting air blown on it from the system.
Sure.
So it will actually read the correct temperature in the house and do what the system is supposed to do.
It's a good point. I never really thought about it or, considered it in the way that you just said on the heating side too, right? You're throwing all those BTUs out on an oversized furnace. And so, it gets real hot real quick. But then it starts to drop back down. Instead of getting that run time and letting just the surface temperature of all the things in the house, the ambient temperature, just warming everything up together and consistently, instead of that bang, bang, off on.
Correct.
Yeah.
That's where the two-stage variable speed systems and the modulating systems like you have in your house, they are designed to run longer amounts of time. They want the blower to run full time so that we're constantly circulating air, taking hot and cold spots out of places in the house.
Yep.
And it has the ability to obviously ramp that fire up and down. So we're not just, boom, 100% heat, 100% blower, here we go. And then, it might run for 15 minutes shut off, but then, grandma's over there and
freezing in the far northwest room of the house.
Right, exactly.
Yeah, so that's a modulating burner then, that technology. When we were talking about a gas furnace and that burner, is that a modulating burner?
Well, it's the gas valve itself is what modulates.
Got it.
Not the burners or the byproduct of the gas valve.
Yep.
So you've got what's a two-stage system. We have furnace will fire off at 50% of its capacity. And after 15 minutes of runtime, give or take, it will ramp up to that next stage. It'll open up 100%. Here we go. On a modulating system, it has the ability to drop all the way down to about 30% of its capacity. Yeah. And it will open that valve in 1% increments and find that sweet spot. And then it learns that, and then that's where we go.
Yeah, that makes sense. So, that's so the furnace can modulate up and down. The compressor can modulate up and down. One of the things, and one of the reasons this is important on an energy efficiency side, as well as, the environmental, like I said earlier, I remember as a kid, my family was in the heating and cooling, refrigeration business. I remember my dad and my grandpa going back and forth. My grandpa would be like, well, let's just get the 150,000 BTU furnace and throw that in there. And my dad's like, why, Dad? You don't need that. Well, it's only $50 more. Let's just get the bigger furnace. Right. And that used to be the mindset, the old American muscle, the bigger the motor, the better. But now with this equipment here, say a house is calling for maybe 2 tons of cooling. Well, maybe you end up putting in a 3-ton system, but with this inverter-driven compressor, you can throttle that up and down between, 30% to 100% of its capacity, like you were saying earlier.
Correct.
And the sizing aspect of it, you get a little more forgiveness, maybe is a word on the sizing.
Yeah, well, absolutely. And especially on a heat pump system, we're not going to size that system for the cooling side per se. We're going to size that to the heating BTUs, and there again, that's where the inverter-driven compressor comes in, because we might need 3.5 tons BTU-wise to heat the house, but we only need 2 tons to cool the house. So it learns that as well, and then has the ability to ramp that compressor down to give us only that 2 tons of cooling, as opposed to throwing 3.5 tons of cooling at it. And now we're in a situation where the house is cold, yes, but it's clammy. It doesn't feel comfortable.
Back to not getting the runtime again, right?
Right, exactly.
So you said something there, and I wonder if you meant it that way. You said it learns that. So do these systems actually log the data, and are they saving?
Constantly tracking and monitoring and learning. They are the Mitsubishi system. Wow. The way the control boards are set up, which was actually fun the last couple of days at the Mitsubishi lab, that we were able to get hands on and play with them and kind of track, all the different diodes and everything that goes into these boards and what they're doing and how they're functioning, and it's amazing. They're about as smart as your smartphone or smart thermostat or anything else anymore.
All the technology that's packed in there.
It's ridiculous really cool. What they've got put in these systems.
I know that, like you said, in my house, I've been really, really happy. Unfortunately, I don't have the Mitsubishi, but I've got a really great unit out there. It's the Carrier Infinity series, I think. But I've been really pleased. I went from a 4-ton AC single-stage compressor, and we got the Infinity, which has the variable compressor there. And I often will see that system's running at 0.75, so not even 0.75 tons, which is stage 1. And that's where that thing's running at often. So, I mean, on my house, a pretty big house, to be using that small amount of cooling, and it's because it's that consistent runtime on it. And I can feel the difference. I mean, it makes a big difference in the house.
And that system itself, it's amazing with the dehumidification of that Infinity.
We feel it.
Yeah, it's amazing how that, right in there, that's kind of like the infancy. I feel like some of that technology might have been what Mitsubishi kind of mirrored after, because that communicating system that they use and the way that system will ramp itself up and down, and it kind of learns what run times and senses, right? Okay, so we're 60% relative humidity. Well, that's not really what we're looking for. So let's let this system run just a little bit longer. See if we can't get that down closer to that 50% range in the summertime, which is where you're going to start to feel more comfortable and be able to turn the thermostat up a little bit, because dehumidified air, it's not right. It's going to feel more comfortable to the skin and everything else, as opposed to it's 68 degrees, but I'm not really getting rid of all that moisture like I should be.
Right. Yeah, that's a good point. Yeah, people might not realize that is typically the enemy when you're trying to make your house more comfortable in the summertime. It's really the moisture in a lot of cases. And so that's why it's important. But man, as we talk about this stuff, this is one of the more, probably the thing that I'm most excited about in the Greenlink world right now is the HVAC side, is this technology, because it's just so amazing. It's very fascinating to me, and the impact that it's going to make for people as they get these systems is really cool. You guys just installed a Mitsubishi full blown system for a customer this past week, over the last week or so.
Correct.
And I mean, this guy, what did he had out there before? He didn't have a central AC system.
He had not had central air conditioning in over 10 years. He was using a window air. His AC wasn't even hooked into the system. It was sitting out there, but it wasn't.
Like somebody like stripped it out or something.
It was not in good shape. It was doing nothing but housing chipmunks and things like that. And he had an old 15, 16-year-old 80% efficient furnace, which is probably was costing him a couple $100 a month in the wintertime to heat and cool his house. And he was using window airs. So now we've gone into a situation now where he had a leaky old house and inefficient equipment, and now we've gone in and we've tightened his envelope. We were able to put smaller equipment back in to be able to do everything, and so much more energy efficiency than what he's got going on.
That's right.
He is unbelievably happy with everything that's going on.
Yeah, it's a really, really cool project. And that that's actually through one of our programs, as you know, ComEd's Go Electric program, which is an amazing program, amazing opportunity. I recall as I was speaking with this customer, he was eligible, through ComEd. They said, hey, you qualify for this program, and they got him all approved. And you and I both had a couple of conversations with this customer. He was very, very concerned. He's like, am I going to end up spending more money over time? Is this worth it? Should I be doing this project? And you and I are both seeing this. We're like, absolutely, yes, you should be doing this. But obviously want to respect and be, sensitive to his cautiousness and concerns. And so we spent several hours cumulatively between the two of us having these conversations. And now that we're in that project, I mean, from what I hear, I haven't spoke to him recently, but I hear he's over the moon.
He is absolutely over the moon. He cannot. Probably at least 10 times a day when we're in this customer's house, he is thanking us, and he's so unbelievably grateful. And it is a big thing for somebody to go from that traditional gas-fired mindset, but like you said, by us educating him, now he understands. Well, yes, is your electric bill probably going to go up a little bit? Yes, but we just eliminated a complete utility bill for you.
Right.
You're no longer going to have a gas bill whatsoever. So that's going to kind of transition over, and the way the system works, you're probably not going to see that big a spike. You're going to see a little, obviously, because everything is electric now.
Sure. Yeah.
But what was it costing you to heat your home in the summertime?
When you add both sides of those bills together.
Correct.
Yeah, that's a big deal. And again, this program is the Electrification program. I don't feel necessarily entirely partial saying, hey, you've got to only electrify and that's the only way to go here. That's just the way this program happens to be. But we're big fans of dual fuel, which we touched on a little bit earlier, and you started talking about the IntelliHeat, where somebody can say, like, I guess my house, for an example, I didn't put in a heat pump, a couple years ago when I did this system, because I just wasn't as aware at that point.
Sure.
So I've got a gas furnace and an AC, but I would have that option to say, hey, this is a nice, new gas furnace, and it's got all the bells and whistles, but I also want to stack a heat pump on this. And with Mitsubishi's IntelliHeat, we can go in and we can retrofit that.
We can absolutely do that.
In the best of both worlds.
Correct. Yeah. The way they've designed the system is that basically it's their evaporator coil and their smart controls. So we can add that heat pump to an existing system just by changing out the evaporator coil that sits on top of the furnace.
Right.
And then running new lines and setting a new outdoor unit. And then bam, now you've got a super efficient heat pump out there, and still the ability, and we do live in Illinois. We're going to get hit with another polar vortex somewhere along the line, right?
For sure.
It's going to happen. So you do have that ability then to still have that gas-fired furnace as a backup heat source, which is
great, man.
It is the best of both worlds. It really is. I'm excited to start putting these systems in.
Yeah, and there's something else. I think it was the IntelliHeat. I don't know. You'll have to tell me where you could have these kind of zones, right? Where you could have a mini split up, like think of a bungalow or an A-frame.
Correct.
You could have a mini split up there, but then you can have a forced air tied into your forced air system down below.
Correct. So Mitsubishi has what's called their smart multi or multi-port system. So we can put an outdoor unit outside that either has multiple ports on it that we can run different line sets to, or we can set their smart multi outside, which is one line set that comes in, then it goes to a branch box, and from that branch box we can run our refrigerant down to the evaporator coil that sits on top of the furnace, and then also shoot it out. So if we have a room upstairs that's just constantly hot, we can put a 1-ton cassette hanging on the wall, and now we just add cooling to just that room, and it all runs off the same unit outside.
That's crazy. And is that same system that you were telling me about earlier that can be, part of it can be cooling and part of it can be heating?
At this point, it will only be one or the other.
Okay.
But Mitsubishi has currently got them going over in Europe and in Japan right now, where they have taken their City Multi, which is their commercial brand.
Got it.
And right now that one can do heating and cooling at the same time.
Simultaneously from one unit.
Within the next 12 months, they're planning on releasing that system in the United States here. So we'll be able to put a system in for somebody that if you're sitting down in your basement and you need heat down there because it's cold during the summertime, but your wife needs AC upstairs, you can be doing that simultaneously through the same system.
Wow. Yeah. I'm going to definitely be checking into that. That's pretty cool.
It was, I nerded out a little bit the other day when he was explaining
exactly. If for nothing else, just the nerding out and the technology is so fascinating. It's like I gotta see what's up with this. That's pretty cool stuff
for sure.
So we're talking a little bit. This is kind of in the same line of thinking, and we talk about buttoning up houses, making them more tighter and energy efficient and comfortable, and we talk about the HVAC. But there's a piece in that HVAC which is the ventilation aspect.
Sure.
And you were having some conversations about that. You got the ERVs and HRVs. You got the bath fans on timers. We typically go with the bath fans on the timer. That will satisfy what we need to bring in makeup air and fresh air into the homes. Maybe tell us a little bit about that bath fan configuration and method that you were doing today to install for this particular customer.
We installed a Panasonic Select Whisper Green fan, which has the ability of adding either a moisture sensor or a motion sensor, so it's smart enough to know if you walk in the room, it's going to kick it on. But if it's not sensing that moisture, it may only bring it on at, say, a third of its capacity now, and then all of a sudden it senses some moisture. Now it has the ability to ramp that up to 100%. We can set it so that it is constantly moving airflow in the house, which the new International Energy Code wants X amount of air exchanges in the home per hour because of the tightening of envelope. We need to constantly be moving that air around. So this fan has a built-in timer system that we can tell it, hey, I want you to run 15 minutes out of every hour, and it'll kick it on, do its thing, shut it back off, and it'll only run it at, say, again, like a third of its capacity. But then when you need it, right, when you go into the bathroom and you need to do something or somebody's taking a shower, then it has that ability to go to 100%.
It's that full throttle.
Correct.
And what's cool about that, when it's in that continuous mode that you're talking about, continuous ventilation, say you dial that down to, say, 30 CFM, whatever that lowest setting is on there. So that fan is always on at a minimum at 30 CFM. With this DC motor, it's so efficient. It's so quiet. Yeah, you don't even know the thing's running.
Unbelievable.
When I come home, I just install one in my house, and I've been kind of monitoring and seeing how it's working. I'll go up there, and I got to kind of like turn up my ear to the ceiling and see if I can try to hear anything going, because it's a whisper, right?
It really is, right? When we fire them up, the homeowners are always like, is that thing running? You got to take a piece of toilet paper and you got to put it up on the fan. You're like, check it out. Yeah, it's running. I promise.
Yeah, for sure. That's definitely the way to go, the tissue test. I love doing that. That's great, man. So ERVs, HRVs, have you ever installed any ERVs before?
I have not actually installed them. I've worked on plenty of them, cleaning them, maintenance, stuff like that. As it sits right now, you typically only see an ERV in a real large home, 5,000 square feet or more. Yeah. They're typically ducted in from outside, and then we duct into the duct system for the furnace and air conditioner. And it basically is it's got its own little built-in air conditioner heater in it, so that we're not just, obviously, if I've got a 6-inch supply that I'm bringing in from outside and it's 10 degrees outside, I don't want to throw 10-degree air into my air that I'm trying to heat the house. So it will run through that system and bring it up a little bit so that we're not introducing that real cold or real humid air in the summertime.
Yeah, that makes sense. So that ERV will actually help as it goes through that heat exchanger exchange process. Will it help lower the humidity or dehumidify in some sense as it's coming through that? I'm not sure, honestly.
It's really more of an air exchange product, but it is dehumidifier. So in the summertime, yes, it absolutely is dehumidifying the air that we're introducing into the ductwork.
Right.
So when we're bringing in 90-degree hot, humid air from outside, I don't want to throw that into my duct system that I'm trying to dehumidify and cooling the air
and condensing. And
they're a little bulky right now. I'm hoping that down the road here they try and tighten those up a little bit, because they can. I mean, they're 3-4 feet wide and
I've seen
2
them pretty
feet
large.
They're pretty sizable pieces of equipment, but they do run great and they do their job. That's really like when you're talking complete air exchange, bringing fresh air into a house and exhausting air out and stuff. The ERV system is. They've been doing it for a long time.
That technology is not new, right? ERVs, it's been around a long time.
No, absolutely not.
And why that's important is, homes need a certain amount, like Jarron's been saying here, a certain amount of air changes per hour. It's part of the code. It's necessary to, keep the indoor air quality intact in a healthy place for homeowners. But then also for combustion appliance zones, if you still have a gas water heater, natural draft, and you've tightened up that home too much, there's no way for that flue to draft properly. As it starts, the heat's rising. It needs to replace the air that the house is losing as it's drafting through the flue. And if it's got nowhere to pull from, that CO is going to start to spill back into the house.
Correct. A good analogy to kind of think of when you walk into a restaurant and you try and open that door and then you feel like you need to go really work out for an hour just to be able to get that door pulled open. That's because we've got such a negative draw in the building because of their massive range hood that's sitting on top of their stoves. They're not introducing enough makeup air back into the system. So we're just constantly in a negative pressure where we want that happy medium where we're exhausting, but we want to be putting back in what we're exhausting at the same time to keep us at a balanced, positive pressure.
To give take, right? You got to you breathe in, breathe out type situation. I never realized that was why that would happen. I thought maybe that was a part of their design where for some reason they would be under negative, but then you see other places where they have that first breezeway is a positive pressure.
Sure.
And that makes sense to me. I think that's by design where they're trying to stop that cold air from blowing into the building. They're pushing out the warm air, right? Is that the strategy there?
A lot of places, like if you walk into, local Meijer grocery store or whatever, they have what's called an air curtain that sits right above that front door. So when that door slides open, that blower kicks on, and now we're dropping that warm air. So we're not
kind of combating the cold air that's wanting to blow in through the building.
Correct.
Yeah, that makes a lot of sense. How about into the ventilation, purification, filtration? I guess we covered ventilation, but purification, filtration. What products are out there? What are you seeing in some of your trainings? Obviously, like UV lights are a thing. What other things are out there, and what do you know about that?
UV lights are a big thing, right? After in a post-COVID world now, every hospital across the country has UV lights installed in all their ductworks. They already have a high HEPA filtration system, but even a lot of those have gone to an electronic air cleaner where they're actually capturing and killing as it comes through the filter system.
Bacteria or whatever is coming through.
Trane has one called the Trane Clean Effects, which is probably one of the nicer ones in the market. That does a capture and kill system where it's got an electrified filter and then a really heavy-duty HEPA-style filter to catch and clean that. So if you've got somebody that has allergens, pet dander, you're a dog people, but your wife is absolutely just allergic to dogs. A combination of that UV light and electronic air cleaner, or even just a media cabinet, which is just taking and getting rid of your 1-inch filter in your furnace. Because a real common misconception out there is that if I spend $30 on this 1-inch filter, it's going to filter the air for me and it's going to do all this stuff. The 1-inch filters are only designed to protect the blower. That is all they're designed to do.
Got it.
3M, when you put that real tight 3M filter in. But they're like $30 a filter or something like that. The way they get their efficiency is by tightening those pleats so much. Now we're reducing the amount of airflow. So in essence, we're giving the HVAC system asthma. Yeah. You can usually, if you have those filters in, you can lift that guy in and out, and you will audibly be able to hear that blower change. Right. And one of the biggest problems with that is, you're calling me in the middle of the night saying, my furnace keeps coming on and off and it's not running properly. That's because it's tripping on the limit because we're not getting enough cold air back in. And in the summertime, it causes an air conditioner to freeze up because we're not moving that air past those real restrictive 1-inch filters will actually cause so much drag on the system that it will slow down the blower rotation, so we're not moving the correct amount of airflow. Yeah. So we can take that out and just put in a 5-inch wide cabinet that has a 4-inch filter that is actually filtering the air out. Sure. Like those filters start where those 1-inch filters kind of stop off. Yeah. That's right. Step one, you can do that with an ultraviolet light in your ductwork. But if you do have really bad allergies, then I would probably lean more towards an electronic air cleaner. So we're not only sterilizing it with the UV light, but we're capturing and killing anything that's coming through back in the system.
That's very, very interesting. I have all kinds of thoughts on that. One of them is I've been there. I've been that homeowner where I got the super tight, super hypoallergenic 1-inch filters. I thought I was doing something good for myself there, and I restricted my blower so much that I came home one day and it was in the summertime, and my house is at 78, 82 degrees, whatever it was. It was hot in there. And I go downstairs, I'm looking around, and I flip the switch. Next thing I know, I start seeing water dripping out of my A-coil. I'm like, okay, I see what happened here. I froze up that A-coil because I was restricting that airflow so much.
Correct, and it was probably a brand new clean filter.
Yeah, that makes sense.
Another thing that gets them, and I don't know what the deal, why they say that there is no such thing as a 90-day 1-inch filter.
Got it.
And if you're using those super high efficient 1-inch filters, you should be checking that thing at least once a week and probably changing it every 2 weeks to every 30 days. Yeah, there is no such thing as a 90-day
filter. Plug up and restrict the
absolutely
the blower so much. What is that called? The static pressure of the system is affected so negatively by those filters in some cases, and with these DC driven blower motors, they're sensitive to that static pressure.
Absolutely, they're very sensitive to static pressure.
Yeah, so it's important to make sure that filter design is correct and that you're considering all these variables. But one of the things that came to mind as you're talking about this, I think about the Greenlink process 360, but we'll set solar aside for a second. Just talking about the building envelope and the mechanical piece, I can't see anybody else that would be better suited to go into a home and really assess and help improve that indoor air quality, because we're controlling the outdoor pollutants by sealing up the house, running the blower door. In that case, we're also obviously the ventilation with the bath fans. We're getting moisture out of the house, looking at the VOCs that potentially may exist in the house. And then you start getting into these mechanical systems with the electronic filters and the UV lights, all that stuff combined together. I mean, that is the full package to really maximize indoor air quality in a house.
You're absolutely correct. I mean, getting into the mechanical world, I feel like was a very natural progression for Greenlink based on what was already being done as far as the home envelope tightening and everything like that. To circle back, you just mentioned the ventilation part. A lot of these exhaust fans, range hoods in people's houses, they're not vented outside. They're just blown into the attic, right? So when we're going in and we're changing these fans out, we're going up and we're cutting a roof penetration and we're running that vent all the way up through the roof. So we're not just dumping that hot, moist air from your shower into your attic where we're going to create a mold issue.
So it's more about just I don't know what they were thinking back in the day. It's so common that I don't know when builders learned and remodelers learned that this was such an important thing. But at some point it's like, hey, out of sight, out of mind almost or something. I mean, I'm sure it wasn't malicious, but it's so consistent in these houses where it's just dumped right into the attic. And even in some newer houses, I mean, it's been code for a long time, but a house that's maybe built in the 2000s or late 90s, you'll see that it's not just a house from the early 1900s. I mean,
it's not.
Decade or two old houses where you'll see that situation.
I mean, a lot of your inspectors are not climbing up into an attic to see, right? Yeah. They see a vent hole in a soffit, so they assume that somebody did their job and ran it properly. But
well, interestingly enough, on the soffit side, and I think that's okay with code. I think they allow that where you vent a bath fan through the soffit. I typically
do a puck vent.
Yeah, puck vent. Yeah. Yep. I try to avoid that, but in some cases we have to. But what I've seen before, and it was really interesting to me, It was, say February. It was really cold outside. I was up in Rockton doing an attic assessment, and I'd seen up in the attic a swirl pattern of the frost coming in on the left and right between the center bay where the duct was being vented out into the soffit. What was happening is it was venting out, and the intake was bringing it right back in. And so that moisture, and you could see the air movement frozen with the moisture that it was carrying up to the roof deck. It was really quite fascinating to see, to see the pattern like that. And that was when I was like, okay, that's a problem. We got to be careful and avoid that.
Absolutely.
And so when we can, where it makes sense, we try to just get it out the roof. That way we know we're not jeopardizing bringing or reintroducing that moisture back into the house.
Yeah, absolutely.
But, cool. That's good stuff there. But you talked a little bit earlier about manual J's and, the sizing of the equipment. And so let's just talk a little bit, before we start to wrap things up here about the sizing. What is a manual J? What does that mean? Why is that important? And how does that, impact the customer's experience?
So a manual J, another word for a manual J would be a load calculation. So what we do is we go in and we measure rooms. We're looking at windows to see what the R value is. Are they a single pane? Are they a double pane? Do we have argon gas in there? Yeah. How is the window insulated? Is it sealed? How much insulation do we have up in the attic? Are rim joists sealed down in the basement? Yeah. We take all of that into account and we plug into a program, and that program calculates all that and tells us, okay, based on this amount of insulation and these windows and this, the house was built this way and it's facing this way. It takes into calculation whether we're facing south, southwest. It tells us then we need 36,000 BTUs to cool this house properly and 60,000 BTUs of heat to heat properly. A lot of contractors are just going in and they say, all right, well, you got a 100,000 BTU furnace in here now. Your furnace is dead. You need a new one. We're just going to put a 100,000 BTU furnace back in. Well, you know what's going to happen? 5 years down the road, you're going to be calling somebody because you're probably going to get a crack in your heat exchanger because it's not running properly because the furnace is grossly oversized. It's popping on and off, on and off, on and off, so it's not running properly. So when we go in, we do that calculation every time to make sure that we are sizing it properly, not only for us, but for the homeowner. Right. The properly sized equipment, better energy efficiency. Or not, right? Sure. The run times, that all kind of factors in. The way the industry is going is trying to put smaller equipment in to cut down on the amount of
energy usage,
the energy consumption.
Yeah.
Absolutely.
Yeah, and so the energy consumption, and there's no trade off here. I think when I was younger and I was first getting into this, for some reason, I kind of had this thing in my head. It's like energy efficiency means that I'm giving up something on my side. Like I'm giving up a little of my comfort, or it's a trade-off. And that's really not the case. I mean, energy efficiency, when you bring this all together, it really complements the comfort of the house and the air quality.
It absolutely does. The way, with the 360 science, with what Greenlink does as far as tightening the envelope of the home, and the whole industry is kind of going that way now.
For sure, yeah.
We're trying to get away from using as much natural resource and going to a more renewable energy because at some point there's going to be so many we're going to run out. Exactly. Right. So to go in and be able to size that equipment properly, and I think the customer will find that they're going to get better dehumidification out of their air conditioning system when it's sized properly and it's running like it's supposed to, as opposed to on off, and we're not really getting the benefit of what the system is supposed to be doing.
That full run time. Yeah, and I think that's, like you said, it's a natural progression for Greenlink, and it was always part of the vision to add that third piece. When I talk to somebody that is not as into the industry, and they hear, well, we're doing solar, and we're doing envelope, and we're doing HVAC, some people are like, whoa, that's crazy. You're doing so much. Why are you all over the place? We're not. We're very, very focused. Sure. And it's because these systems all work together, and we have experts like yourself and like Dave on the solar side that have the expertise within your craft, your trade, but then you also have this broader understanding and team to collaborate with to really bring it all together for the maximum, product and performance for the customer.
Yeah, absolutely.
So cool, man. Well, I appreciate the chat today. This was a good conversation, and I think throughout the year here we're going to have a lot more to talk about, and we'll come back and revisit, and maybe even talk about some case studies and how some of these systems are performing. So.
Yeah, absolutely. I'd be happy to.
All right, man. Thanks.
Awesome. Thank you.